I'm welcoming everyone to the second day of Agility today. I think we are going to the end of the sessions. You might be already tired with a lot of information. How are you so far? Feeling good? Great? Okay. Great. So, lot of learnings you want to go back and implement, I believe. Okay, so this is might be slightly different topic. I'm more concentrating on the technical aspect of agility than the people side or cultural side of things. So these are most of the things that almost all of the things that I'm sharing here are from my personal experience, and none of them are like new here, but what I learned from different books or different people, and then I'm sharing it what worked for me to keep up with technical agility. Okay, so just to understand, how many of you are programmers here who write code on a? Okay. Others are what different kinds? What roles? Coaches, agile coaches, or what different roles you play? Okay. Okay. Mostly on the managing side of things. Okay. So I am a CTO slash co-founder of a company called Good Karma. It's a SaaS product that we are building. The product is to help them our customers market better, okay, to their potential customers or leads. And when you are working on products, I think especially new products, you know that one of the things is that things keep on changing. So we started 3 years back. At that point of time, we started it as a CRM product because that is where we saw the most problem our customers have. And then after we built our product and released to our clients, we realized that okay, there are more areas there we need to focus on. So we pivoted from CRM to a different area, that is the marketing now. So it undergoes maybe sometimes very drastic changes for your product, sometimes very small changes, but most of the time what you started off with, that may not be what you end up with after a few years. So you have to cope up with your thinking, your architecture, your design, everything to cope up with those changes. Okay, and one of the things that we believe is that we need to release often so that we can get more feedback from our customers. You cannot keep building and after 6 months or 8 months you release it and realize that okay, that's not what the customers want. Right? You wasted your time, your money, everything into that, and you get frustrated. Okay, so you get more frustrated by releasing more, but the idea is that you can change faster when you are releasing more often. Okay, so that's the reason why this mantra works. So the key thing over here is iterations, and like I mentioned, product evolves. Right, you don't build the entire product on day one. Right, it evolves after you release to market. And if you are not evolving, that means you are not learning enough from the customers, and it may not grow. Right, you may get some money initially, but it will not be sustainable. Only way to become sustainable is by learning, and that will definitely result in evolvement. But how do you evolve architecture? That's the question, right? How do you evolve your major designs, right? You decided certain things on day one, but after a certain time you realize that okay, things have to change. Then how do you do that for an architecture? Okay, so just as an example, we are using when we built our CRM product, we have a IVR solution that we give to our customers, so that we get IVR numbers and then we give it to our customers, provide it to them so that they can manage all the calls that they are getting. Okay, we started off with one service, then we realized that service is costly, and also their customer support sucks. The service is not reliable, so sometimes the calls doesn't go, or even if it goes, it is not clear. Okay, and then when we report it to the customer support, it takes sometimes even days for them to fix it. Now numbers are not available at all sometimes. I mean, the number doesn't work at all. So we realized that these problems exist, and we found another provider to move to. But the thing is that we have we have a solution that works partially, and we have found this new one. So completely moving to this new service for our existing customers takes time, and not only that, it's very risky. If the new service also, in the paper it looks good, but when you actually implement it, does it really work, right? That's a big question. So what we did was, we did parallel. We started off with new customers on the new service, and we used the existing customers, they continued on the old one. And once we got the confirmation that the new service is indeed better than the old one, we moved everyone to the new one. Okay, so this pattern is actually called as, so this is how we implemented it. We have a certain set of implementation that we had earlier, and then that is the old implementation. So our earlier customers continue to use that. We wrote the new implementation for the new IVR provider, and then that is what our existing customers use, the new customers that we are hiring. And after some time, we completely kill the early one, and that way we are not dependent on the earlier service. Okay, and this is nothing new. This pattern is called the branch by abstraction pattern. Okay, so you write an abstraction layer, and depending upon what kind of implementation you need, you redirect to that. Okay, so the thing over here is that you can easily switch between implementations when you have when you are starting something new, this works. And also when you have multiple implementations, even if one thing goes down, you can just quickly switch to another one by just changing the layer. You don't have to do a lot of changes. And if you can keep that as a configuration, then it's just a change in the configuration. Okay, and this pattern really works well. And apart from this pattern, also use, and this is a concept from domain-driven design book called anti-corruption layer. That is, you have a layer, especially when you have external integrations. Okay, and the changes are restricted to that. So your code always talks to the layer, rather than across the code you are talking to the external service. And then when that external service changes, you have 10 different or 100 different places to change. Okay, this is standard or layering mechanism, but combining this with branch by abstraction helps you to quickly change your major architectural changes. Okay, you can do it for even your frameworks. If you are changing your web framework from one to another, you can apply the abstraction layer and do it, rather than going into a branch, doing it for 6 months and releasing it to customers. You can have both the frameworks in production. Okay, and this.
What is anti-corruption layer?
Anti-corruption layer. So if you have a service that you are using, entire interaction with your service is written in a layer, and your code just talks to that layer. It doesn't directly talk to the external service. In that way, if you want to move away from that external layer, that service, and put another service, you are still continuing to use it's abstracted out. It's a standard abstraction mechanism, nothing new here. But this kind of patterns, using it regularly, helps you to adapt changes faster. That's what I'm trying to emphasize. Abstraction. Strangler is different. I am coming to Strangler.
Get back to moving all customers at one go, or keeping them there, and this problem that you stated, right? There was a problem. You were not happy with the services.
Yes.
Then you tried out a new service provider.
Yeah.
All new customers here, and none from the existing one there. So what it meant was, you had already realized that there was a problem.
Yeah.
So you let the existing customers probably for some more period until you validated.
Yeah, this one. Yes.
So it would have been something like a strangler, like where it probably move some of the customers also as part of that validation. It would have its pros and cons.
Yeah. I mean, yeah. So the reason why we started with the new customers was, in our case, in the case of an IVR change, they had to literally change the number in their website. which is very, very difficult for them. You can't do that for many times I mean, if the new service doesn't work, if they have to go back to the earlier service, they have to change their number, and that is not something that the customers wanted all the time. So that was one of the reasons we didn't try with the new existing customers. But in some cases, what we've done is we can do the other way. So it depends, but the idea is the same, right? Whom to deploy to new service and the old service depends on the context, but the pattern is what is more important. Okay. And this is another pattern, strangler pattern. I think you already mentioned this. This is similar to branch by abstraction, but this is more on the application level. If you want to, so when we moved from, so we are currently building the second version of the app called the second version, we call it as GK2. So we are slowly killing GK1, right? We are when we are building new features in GK2, we are redirecting it from GK1, and then we are killing our code there, and then it is redirected to here. But entire features in GK1 is not moved to GK2 yet. It may take maybe another couple of years. We may not move some of the feature at all. We don't need it. Okay, so this is very, very good. So, but usually you see this when you are killing a monolith and create microservices. But in our case, as we are not a big team, we are still with monolith. So in our case also it works. We may end up with microservices down the line, but we don't know. But the idea is that when you are killing something old and then creating something new, you do it in a continuous fashion using this pattern. Rather than what we have seen is that teams goes into a 6-month period, write all the code and come back and release it. You don't have to do that when you are using these patterns. And this gives you quick feedback from the market. You are directly testing it with your actual users. Okay. What about databases? Can we apply similar patterns to database? I'll explain with an example what we did. So we had a concept of trial bookings. So someone can call the IVR, book a trial class so our customers are mostly yoga centers. So they want to try out the classes before they join there. Okay, so they can book a trial class using the IVR system. Okay, so we had these fields in our bookings: who booked it, when they booked it, and what is the status of the booking. Okay, then after a while realized that the status field is overloaded. Status can be whether two things we need to know: whether they attend the trial, and after they attended it, did they join the studio. So two things we are storing there. So we wanted to split it so that it is easier. It's not overloaded, and we can come up with reports and other things very easily with that. But how do you split it? Because we already have a lot of data. You can just change it. We also have mobile apps. We have APIs and other things. So it's not like you can just change it on one day and release it, right? And that too, it is risky, especially because we are moving the data from one field to multiple fields. So with that also, we did it in a continuous delivery manner. So what we did was, we had the status field, which is an old field. We added 2 more fields. We took the data from that and stored it here. Okay, and then this is the expanding mode. Okay, we have old implementation as well as the new implementation. We wrote enough scripts to make sure that when we update the old field, the data is updated into the new fields also. So the idea over here is, with small steps you release to the production. Even though the new fields are not being used, still the data is getting synced. Okay, and keep on syncing it, and this is how it will be when you have both of that. Once you get enough confidence, and once you make sure that everything is integrated correctly, you can delete the old one. This is the very safe manner. You can do it if you want to split it to multiple tables or anything. Okay, the same pattern you can apply. So this idea comes from this book called Database Refactoring. It has a lot of patterns about how do you manage your database in a manner that it doesn't break things, in a less risky manner, because all of us know that the databases are very risky. If that goes for a toss, it's a big problem. Okay, so this is Pramod Sadalge. Okay, this pattern is called expand contract. Similar to the branch by abstraction, you have multiple implementation. You expand it to the new implementation, then you contract to the kill the old implementation and contract it. Okay. The basics for all this is the starts from the idea of refactoring. Doing small things, and after doing a lot of small things, you get a big one. Okay, and that is a fundamental, and it enables you continuous delivery. With each change, if your tests are passing, you can safely go to production. Okay, and it should not break, and then that is how you should, but it has to be really, really small. And you traverse it to the pipeline. Okay, and the idea over here is you continuously integrate. The problem with branching is that when you integrate it after a long time, you have clashes and you may break things. And then merging that is a useless, it's a waste of time. And in this way, everyone can work on single branch, and then that can be deployed. There is no waste of time, everyone's skill is used in the right way. And trunk-based development. And it is not isolation. Continuous integration has to be integrated continuously, right? At least once in a day, multiple times a day. That is how the target should be. But one thing that might be a problem is when you have experimental features, how do you manage that with say things that may require some kind of a sign off. You don't want to open it up in the production. How do you do that with trunk-based development? And that is where feature toggles comes into picture. I'm quickly ran through it. I think we are running out of time. We have three kinds of feature toggles. One is release toggles, where you want to turn or turn off things depending upon some environment. You want to turn it on only on staging, not on production. Okay. Or you can really use it for experiments. Open it up for say short 1% of your users, few users, or some part of the world, or some kinds of users. Okay, and ops toggles. This is one thing that might be different than others. These are not for experiments. For example, you are depending on an external service. That service is not working well. You want to turn off certain features because that service is not working well. So these are like operational things. Depending upon how your load is, you may want to take some calls. Best example is in Netflix. You see recommendations, right? If the load is too high, they may not load it, or they may not show the very relevant. It may show it from the cache. Okay, so those are okay to be not working well all the time. Right, so those they make a decision on depending upon the ops toggles. Okay, and just some data I want to pull up from something that I've seen. GitHub recently upgraded, I think last year updated Rails version. Rails is the web framework they are using. They did a major upgrade from 3.1 to 5.1 over a span of 1.5 years. But they continuously delivered to production during that time. They didn't work on a branch and then released it to the production after 1.5 years. Okay, so they gradually did it part by part of their application. It's a monolith app. So during that time, they had both Rails versions in production, and it really helped them. Okay, and so mostly people ask, you can't do it for this case, you can't do it for that case. That's the reason I'm pulling out some cases where they have really done it, and you know the scale of GitHub. Okay, and Facebook does expand contract pattern, database refactoring. They do a lot of stuff, and they make sure that always that pattern is followed. Okay, I'll share some of the links in the end of the slides. And then eBay has gone through 4 major architecture change during their entire time. eBay started as a script, Perl script initially, and then they changed to Python, and then PHP, and then they changed to Java. All this while they never brought down the application. They did change to the same application, and then the Strangler pattern is what they've used. Okay, and there are few slides where you can see a few articles I'll share where they have talk about major large scale changes they have applied using this. Okay, so the continuous delivery is the key over here. You continuously, every change should go to production. Okay, and this is the only way to learn from customers is by releasing more often. Okay, And when you say something is done, it has to be available in production. And things will go wrong, and that only way to make it fix it easily is when the changes are very small. If you have a lot of change, it will be very difficult for you to fix it. So do small changes and do it continuously rather than a big bang change. Okay, and build enough safety net, monitoring, tests, and all other automation, so that you can know. Even before your customers know, you should know there is a problem. That is the target, right? If you are not knowing, then there's a problem. Okay, and some of the references I have, these are the books that I've referred for this talk, and some of the articles. I'll be sharing the slides so you can get these links. I think, yeah, we may have some time for questions, right? Yeah.
So the 3 types of toggles that you have today,
Yeah.
can you give us some examples of each one?
I'll go back to the slide. So first one is a release toggle. This is where you want to differentiate between deployments and releases. So if you want to turn off certain features, maybe you're waiting for a sign off from someone, or you are still implementing it. Okay, so that is where this is the most common case, I think. Experimental toggles are where you have the feature, but you don't want to release it to everyone. Okay, so Facebook usually does that. They release it to a few users, or say a few users in certain geography. So, and this also helps you to build confidence that as the number of user base increase, the architecture and your production supports it. The environment supports it. So you start with 1% of the users, then increase to 10% of the users. So you can get feedback about your performance, your other utilities for that matter, using that kind of a thing.
So how do you practically implement this one?
This one are, you say that this on a certain, so if the user is from this the geography, open it. That would be the way they will be doing it. Okay.
Open it first to their internal user and then slowly
But the production system is one, right?
Yeah. So
feature toggle which you can say that and give it only to this setup.
So either it can be based on say if database query say that if the feature if the user belongs to this geography, do it, or if the feature the user belongs to this kind of user.
You are setting some parameters in the database.
Yes. It can be parameterized. Yeah, it can be at the request level also. Yeah, it depends on, it can be, so the first one can be a configuration, pure configuration. Yeah, this one you decide whether you want to have a layer to decide that, either at the request level itself, or you can decide whether it is depending on the database.
Toggles typically it's either available or not available for all. Experimental toggles typically you okay, it is from US from being given.
Yeah. So that, how do you want to do that? It depends on. Okay, yeah. And the third one is the difference between the others and this is that this can be long running. Usually feature toggles you do it for a shorter period of time. After that experiment is done, you kill it. But this can be long running because you want to turn off certain features depending upon certain conditions of your production systems. Okay, or stuff like that. So, or it can be permissions, like this user can access only this. So this kind of things can come here. So it can stay forever if you want, if that can be the case. But other toggles may not stay for long. Okay. So there is an article from Martin Fowler's book which talks about this. So they have written in very detail about this. Yeah. Okay. Thank you. Other questions? I think I have to leave now, so you can email me your questions.